Okay, guys, this is the problem we're going to begin solving today. Is from the 2006 is free response, no calculator, so you have to do this by hand. It's okay. Usually when you have these functions, polynomials or simple exponentials or cliques, are no calculator allowed. When you have something strange, that's calculator allowed. Okay, so the first thing you see is a graph, a strange graph, a piecewise function, where you display calories per minute burned versus time. And then you see that there are different sections here doing the graph, or forming the graph. The problem says the rate in calories per minute at which a person using an exercise machine burns calories is modeled by the function f. In the figure above, f of t negative 140 cubed plus 3/2 t squared plus 1 is the function from 0 to 4. This portion right here, this portion, this is given by this function, okay? Only. Is it? And the piecewise function is linear for 4 to 24. So here is a segment, here is a segment, segment, and segment. Okay, not a big deal. The only problem is this one that is a cubic function and it's right here, okay? Okay, okay. Question number 1, question 8. Find f prime in 22. Okay, indicate units of measure. This is my first question, okay?
There's the slope of the line.
Correct. So
yes.
This is f, this is the function f, correct? So 22 is like right here, pretty much like right there, correct?
-3.
So then what you have to do exactly is that one. So yes, let me just write it. So f prime of x is the derivative of f respect x, right? Let me just put it right here. Stop sharing, right? Oops. Right here. Just put it right here. This is okay. Un poquito más adelante. Okay, there is. So we have that f prime in 22 is the derivative of f respect x in x equals 22. So this is a slope at that point. So obviously you see the graph. The graph is joining the point 20, 15 and the point 24, 3, correct? So those are the points you see in the graph, marking the line. So the only you have to do is get the slope. So df dx is the slope of this line. So the difference of the y's is 3 minus 15 divided by 24 minus 20. This is negative 12. This is 4. And Brandon is right. The slope is negative. So pretty much, remember, you can do this one. Careful. If you don't show any justification of this negative 3, you're not going to get any credit for the right answer, okay? So.
Todavía falta otra cosa, Ramírez.
¿Qué pasó?
Todavía falta otra cosa en la pregunta.
Indicate units of measure. Okay. So F, right? F is...
Isn't it calories per minute squared?
Calories per minute, right? And this is df dt, correct? Or dx, in this case is time really. This is really time. Yeah, it's time. Let me just put here the t, the t, the t. And here is the f dt equals calories per minute squared. That's correct. So the units of the derivative here is calories minute squared. That's correct. Very good. Okay. Very good, engineers. Units are important. So first problem, first question is easy. Let me just go to the second one. Okay. Here says B. For the time interval from 0 to 24, At what time t is increasing at its greatest rate? Show the reasoning that supports your answer. So increasing means that at the greatest rate means the slope of the tangent line is the highest. So vamos a ver. Let's see here. Here is 0 because it's a horizontal line. So here the slope or the rate of change is 0. Here in this point is 0. Here in this point is negative, is the one we got. Here is negative. So we have only 3 places to check, right here and right here, correct? Okay. So here is very easy to know what is the rate of change, correct?
Yeah.
So the slope of that line is 1, right?
661. No, 64. No,
6, 4.
Ramirez.
Let me see.
It's
Let me just write something. 12 less than t less than 16.
It's 6/4.
The slope is, let me see.
6/4.
It's 1.5.
Okay, nobody's waiting. No, I don't think so. Okay. So the slope is, okay, 15 minus 9 over 16 minus 12. So df dx is the slope of the line. So again, I have to do this basic operation. For times between 12 and 16, the derivative of this function respect dx is the slope between these 2 points, correct? So you get a 6/4, 3/2, or 1.5, no problem, correct? No units here, but well, we have to consider calories minute cube. Cube, no, square. Okay. And well, what is the one we have? Well, the other one right here is in this portion. So in this portion, the slope of the tangent line changes, correct? So pretty much looks like by this moment, like right here, you see this one like right here, you have a very, very steep slope. But we have to compute that. So we put 4, 0 to 4, between 0 and 4, df dx is the derivative of the function that appears here. So right here. So that is negative 3/4 t squared plus 3/2, no, well, 3t. That is the derivative. So let me just put the screen here. So right here. Okay. So for the time 0 to 4, the derivative of f is the derivative of the function you have on the paper. And if you take that derivative, is 3/4 t squared plus t. Now the situation here is find where is the max, correct? It's okay. So in this case, this rate of change must have a max. Where is the max point? What is the max for this function? The rate has to be the max. So where you can get this one?
3/4 t squared.
Almost. But remember, I need the max rate of change. So I need the max. This is the rate of change, correct? I need the max point of this function, not from f. So I have to take the second derivative respect x. So that is going to be negative 6/4 is 3/2 t plus 3. And then I have to solve to 0. Correct? So okay, in this point, I'm finding the max or the mean for this function, correct? It's the second derivative. So to find the max of this one, I have to take the derivative of this, right? It's the second derivative of f, and solve to 0, correct? It's okay, let's see. This is going to be how much? T equals 2, correct? So this is going to be 0 for t equals 2. Now, let me see how much is the f in 2. So I'm going to take, okay, now the f dx in t equals 2 is going to be negative 3/4 2 squared plus 3 times 2. So this is going to be 4, right? This is 4, and this 4 cancels, is going to be minus 3 or negative 3 plus 6, so this is 3. And again, these are calories per minute squared, correct? Now, you compare this with this. What is your answer now?
No estoy seguro.
You don't be sure? Okay. What do you think, Leos? Nothing?
Tampoco.
Tampoco?
What?
Well, so the question is very simple. Come on. Is this one. This is for the interval 0 to 24 from here to here, so from here to here, right? At what time f is increasing at its greatest range, correct?
T equals 2.
So the reasoning that supports your answer. So it's increasing at the greatest rate. So the greatest rate is the maximum of the rate of change, correct? So what I did simply is, okay, this is the rate of change of f, the derivative. Now I need the greatest rate, so it's the max point for this function. Well, to get the max, I take this as my initial function, I take the derivative, that is the second derivative now of f, solve to 0, and find the maximal, a max or min happens in 2, correct? Then I take this 2 and I'm plugging here, and I see that is 3. So in between, okay, let me just put this one, between 12 and 16, the rate of change is constant, 1.5. And between 0 and 4, there is in t equals 2, you have 3. So your answer is the maximum rate of change happen at the max of the f change at its max rate at x equals 2, correct? 2 minutes.
Well, isn't it T equals 2?
Oh, well, t, well, you're right. I'm used to use x, sorry. Okay, so everybody clear? Here the trap is not solve this to 0 because they don't want the maximum of this function. That you really see that here. If you see the graph, you see where is the max is all this interval, this is the max. No, what you need is the max rate of change. So you have to take the derivative of this. And from this function, you get the max. And then you do what you know. Derivative equals 0, solve, and then you put this number right here in this rate of change, and then you get the number. And this is more than this, so as a t equals 2, correct? Questions? No questions? Well, next question here. Z, this is find the total number of calories burn over the interval time 6 to 18. Okay, 6 to 18.
6 times 12 is... Oh, that's going to take some... Ugh.
A ver. F of x is, let me just put this one, is calories per minute.
Yeah, you just find the area under the line.
Let me see.
6 por 12. Y luego...
A ver, fíjense bien. Yeah. So remember, engineers, that units are important for you. So let's do a dimensional analysis, correct? Dimensional analysis means this one. F of x is calories per minute, correct?
The integral is calories.
Calories per minute. So they want calories for, burned for and what is 6 to 18, correct? This is what you want to know. Now the function f is calories per minute, so f,
Eso es el velocity.
as you put, ft is the derivatives of calories respect the time, where c is calories, correct? Calories burned per time.
Yep.
Okay, so what I have to do is, well, if I want to get C, I have to integrate both sides. So I have to do my calculus. So I have to do integral dc over dt equals the integral of f of t dt. Now, this is going to be the point. So this is going to be the integral of dc. So the calories in 6, calories in 18, right? Equals the integral from 6 through 18 ft dt, correct? So I have to integrate this function. So this is the integral. So this is going to be C18 minus C6 equals this integral 618 ft dt. Now, there is a problem. You don't have this function given analytically because you have, oh, let me just put it here. Between 6 and 18 is like right here to right here. So, well, a little bit more. So all this portion right here, you see, between 6 and 18. So you need this area under the line, correct? So you need the area right here. Let me just use a marker better. So I have this one. So I need pretty much, más o menos. You need this area, correct? That's the integral. So if I go to my, this is this area under line, correct? So this is the area under the line. Okay, guys, pues basic geometry. Okay, so delete. No. How do you get the area between 6 and 18?
It's what, 6?
A ver. Let's do this part. From
12 por 12, 144.
I have this portion, right?
Se puede hacer más, mira.
This portion, right? And I have pretty much this half, correct? So I need this.
It's 108 for the bottom half. It's 108 from 6 to 20 or 18, I mean.
Okay.
It's 16.
All is great, but you have to write something. Think what you're going to write.
Oh,
This
yeah.
is the integral from 6 through 18 of ft dt is area under graph. So it's going to be one rectangle is
108.
It's 9 times 12 minus 6, right? Yeah, plus, let me just put it right here, what I'm doing. So
minus 6.
FTDT is the area of the graph. So this is rectangle, so 9 is the height of the graph, 12 minus 6 is the difference.
No, it's 18 minus 6, Ramirez.
18?
Okay. Yeah, lo puedes
Yeah,
hacer
it's 18
todo
minus 6.
hacerle todo un rectángulo.
A ver.
Todo lo de abajo hacerle un rectángulo.
Okay, you can do a rectangle. So I like to do step by step. So one portion, and one portion. So see, you can make this rectangle if you want, right? Así.
Yeah.
Y luego le ponen este pedazo arriba, right?
Yeah.
Bueno. Misma forma, right? But remember, this is the point. Déjenme ponérselo así. Why I'm doing this? Because really what we have to write is this one, the integral from 6 to 12 ft dt plus the integral 12 to 16 ft dt plus the integral 16 through 18 ft dt. Formally, you have to tell that this integral can be split in 3 portions, correct? So that's why I went to the little area. So first I took this portion, right? This portion right here. Then I take this portion right here, and then I take the last portion right here, correct? So 3 portions, because your math goes in this way. So the integral from 6 through 18 can be split in 3 integrals, right? Then you put what I did, 9 times 12 minus 6, correct? Plus, now the next one is, okay, it's a trapezoid, so you have 16, so it's, let me see, bases is 12, plus 16 divided by 2 times 16 minus 12, that's the base, plus another rectangle, so is 15 times 18 minus 16. So technically, your answer is correct, but it's not consistent with this definition. What the readers want to see is that you split this in 3 regions that you compute geometrically, and then you get your answer. Esto es 4, 12, 6 por 9, 54. Esto es 4, este es un 4. Y esto es 28, 14. Sí, 28, 14. 7 times 4, 28. Plus 15 times 2. That is at 30. So you have how much? 108, correct? 108 calories. It's the same answer you got, right? Same answer?
Yes.
But remember, the answer is correct, but not the procedure. The procedure the readers want to see is that you know calculus. So this integral is split in 3 integrals. Every integral is an area on the graph. You get your number. Okay? Be careful with those shortcuts. Possibly you get this point, but the other one is not going to be correct. They say, okay, they did work, it's wrong, but the answer is right. So they give you a point, you miss this 2. Or this 1, I don't know how many give for this. Okay? Everybody, remember you're doing calculus. Okay, let's see now, next question. Let me just take this out, erase, erase, erase. Now, the next question is, find the total number of calories. Ya está. Entonces, this by setting, the setting on the machine is now changed so that the person burns F of T plus C calories per minute. For this setting, find C so that an average of 15 calories per minute is burned during the time interval 6 and 18. Okay, so again, the interval 6 times 18. So 6 through 18, correct? Again, the same interval. Okay, now, how can we do this? Average of 15 calories per minute. Remember the average of a function? So let me just put it here in my board. So the average value of a function is this integral. Okay, Let me just put this one right here. Correct? Okay, this one. Okay, so this is the average value of a function. So in this case, they tell you, I want A equals 6 minutes and I want B equals 18 minutes. So that's the interval they gave me. So the average value of the function is going to be 18 minus 6, right? Divided, correct? Not divided, integral from 6 to 18 of f of x of t dt. Let me just f t dt, correct? Now, they want this f equals what? Well, this is 15, correct? So let me just now do the thing they want. So it's ft, this is going to be plus c, right? dt equals, why ft plus c? Because that's the new function, correct? The new function, let me just show you here. The new function is f of t plus c, correct? They want that this new function be and have an average of 15 calories between 6 and 18. So I'm going to do my work right here. So this is my formula. The average value of this f, let me just put it right here. F plus c, like this one, right? The average value of f plus c is going to be this integral, right? So let me just do now, this is going to be 12, this is 112, integral 6 through 18 of ft dt plus 112, the integral from 6 through 18 of c dt. And this has to be 15, right? A ver, what happened here? This is the integral of the addition of two functions, ft and a constant c. I use properties of the integrals. I split the integral of this plus the integral of this, the same interval. The 112 comes from this one, correct? 112, 112 in both. Now, I know this one. How much is this? 112, and this integral, how much was? You got that
108.
integral, 108, correct? Plus 112, and this is z times 18 minus 6, or 12 equals 15, correct? So I'm going to do now my algebra. 112 divided by 108 divided by 12 is, oops, vamos a ver, is 54, 6, 9, correct? Yeah, 9. Plus, this is 12, correct?
1.
This is 12, they cancel out, so a C equals 15. So my C equals?
6.
Correct. Okay, a ver, again, definition. The average value of a function is not the addition of values divided by 2 or something. It's this integral. 1b minus a, integral from ab fx dx, correct? Here, these are the points, so a and b are these two numbers. Okay, this is the function I want to get the average, f plus c. 1, 18 minus 6, integral 6, 18, ft plus c is the one they gave me in the problem. dt equals, and this has to be 15. So I solve 12, and I split the integral, right? From 6 to 18. This integral is the one I calculated in previous example, in previous question, is 108 divided by 12 is 9. This is 12 over 12, c. And if I solve this equation, the c is 6. Okay. Questions, muchachones? Difficult?
Nope. Yep.
It's difficult, believe me. You have to take the time, find time to practice, okay? Really. Okay. Now, we finish with this problem. Yes, we finish. Now I have to move to the end of these problems of this set. So I'm going to move all the way down to the last problem from 2019, you see, no calculator. And now Ray is here. This is the problem. Oops. God, here is the problem. Okay, it's the last one. We don't see a graph, so well, possibly this is going to be analytical. Is in use is very different to the one in 2006. Okay, it says functions f, g, and h are twice differentiable functions with g of 2 equals h of 2 equals 4. So these functions h and j and g intersects in x equals 2. The line y equals 4 plus 2/3 x minus 2 is tangent to both the graph of f of g at x equals 2 and the graph of h at x equals 2. Okay, very good. Now, find h prime in 2. It's $1 million question. Check what you have. The line is tangent to h at x equals 2. Find h prime in 2. What is the value?
Just get the derivative of y and then evaluate it to.
Practically correct, yeah? So what you know is you have to state, okay?
Oh no.
Yes. The derivative of this is going to be the slope, correct? So the slope of this line is this tangent line slope. So the derivative is correct, but you don't have to take the derivative.
The y is already the derivative of g and h.
So h prime of x, right, is differentiable. Let me just write here. Let me just write it here. So y equals 4 plus 2/3 x minus 2, right? Aquí tengo. X is differentiable. Y equals is tangent at x equals 2. Okay, so this is the equation of the tangent line, correct? So df dt at x equals 2 has to be m of the line that is 2/3, correct? Because how do you get, remember how you get the slope of the tangent line? You need a point. The point is right here, right? And then you need the slope of the tangent line, the derivative at that point. So df dx, well, df dx right here at x equals 2 is the m, this m, this is 2/3. Okay, so it's very simple. Only you have to make a little justification. Okay, you have 1 point. Now, let's see the next problem. Let a be the function given by 3x cubed hx. Write an expression for a prime and find a prime in 2. Okay, that's not a big deal. So a function coming from the product of two functions. So you have a of x equals 3x cubed times h of x. So I need to find this. I put it right here on my board. So the function a is this one, the product of these two. And I need an expression for this function, and I need the value of the function in 2. Okay, not a big deal. A prime of x is the derivative respect x of 3x cubed times h of x. Okay, I have to use the product rule, so I have to do derivative of this 9x squared times hx plus this derivative of the second one, 3x cubed h prime of x. Okay, you don't have to do too much. Possibly You want to do some algebra, but it's not a problem. This is 3x squared, parentheses 3hx plus x, h prime of x. So this is correct. You don't have to, but well, you want, you can factor the first two, x squared and 3. That's it. Okay, so this first one is fine. Now you need a prime in 2. A prime in 2. This is the evaluation of these functions. Okay, 3 times 2 squared, 3 times h of 2 plus 2 times h prime in 2. Okay, now this is 12. So this is a 12. This is 3 times h of 2. Well, let's see.
4.
That's a 4. In the problem, you have this as a 4. Then you have 2, and then you found this derivative. What is this derivative? Negative 1. No, positive 2/3, correct? Why? Because we found in the previous section and previous question that this is 2/3, correct? Now I have to do my numbers. So this is 12 times 12 plus 4/3, correct? Okay, so this is, well, let's see, it's 12, no calculator, this is 36, 40/3, and then I get what? 12 and 3 is 4, 160, correct? Everybody catch the idea? Yeah. New function, I have to find these two, find the derivative, okay? The derivative of a product right here. Then I need to evaluate in 2, basic algebra. Then I found the values of h in 2 and h prime in 2. I substitute and I get my numbers. Okay? You have another 2 points at least in this, with this second question, correct? Something not clear here? Everybody clear? Yep. Okay.
Yeah.
Next question. Okay. The function h satisfies that h of x is x squared minus 4, 1 minus f of x cubed for all the x's less than 2. Okay. It is known that limit can be evaluated using the L'Hopital's rule. Okay. Use limit, right? H of x for x equal, when x approach 2 to find f of 2 and f prime of 2. Show the word that leads to your answer. It's okay. Here, well, we have to begin with this one. This is, you see, very different than the previous ones. These questions were not in the previous exams because L'Hopital was not a topic to cover in AP Calculus AB. Now it is, so we have to, well, deal with that. So it's x squared minus 4, let me just write this thing, 1 minus f of x cubed. For x different than 2. Yeah. So limit, we need limit in 2 of h of x. This I don't know how much is this one. This is find f of 2 and find f prime on 2. Let me just put it right here. Okay. Show the word that leads to your answer. It says, oops. Okay. Let's see right here. This is what I have in my board now. This is the h for x equals 2, right? Limit of h of x equals, well, exist. Yeah. This is exist by L'Hopital, correct? And then we want f of 2 and f prime in 2. Okay. Something important. L'Hopital. Let me just put here L'Hopital rule. What is the L'Hopital rule? Let me see. L'Hopital means that the limit when x approach c of f of x over g of x is the limit when x approach c of f prime of x over g prime of x, correct? So the limit of a quotient that is undefined because usually this is 0 over 0, right? When this is 0 over 0 is undefined and you cannot factor something and cancel, then you can go to L'Hopital, right? And try the derivative if this is differentiable, if this is differentiable, and then you get a value, correct? So here says that the limit of h of x exists. So, and remember the limit is the value this function may take, correct? Is what happens. So, can you tell me with this something, any information you can find with this one? We had to use L'Hopital to find this limit, correct? And in L'Hopital, let me just show you here. Where is it? Right there. Yeah.
Can you plug it in first?
A ver. Okay, let's see. L'Hopital is, let me see, I put L'Hopital at the very end, I guess. Yeah. Here is L'Hopital, you see? In your formula booklet, oops, looks weird. Okay, in the in your formula booklet, you can see in page 20 all the L'Hopital things. In this case, we have this one 0 over 0, correct? Why 0 over 0? Because if you put here a 2, right? If you put here a 2, you have 4 minus 4, correct? And the only way this thing is 0 over 0 is this is a 1. So f of 2 is what? Because Rangel said, we put here a 2, so I'm going to put here a 2.
2 over 3, right?
A 2, this is 0, and if I was able to apply L'Hopital, it's because I had 0 over 0. So this is 0 in 2, and this has to be 0 in 2. So how much is f of 2?
3 over 2.
Huh?
3 over 2 or 2 over 3, I remember.
Oh, ¿qué pasó, Leo? Come on. With what value you make this 0?
Oh, 1.
1. So f of 2 cubed has to be 1, correct? Yes? So vamos a ver. Limit of h of x when x equals 2, right, is going to be the limit when x approach 2 of x squared minus 4 over 1 minus f of x cubed, right? And this has to be 0 over 0, correct? Okay, if you put a 2 here, is 0. So this means, right, that 1 minus f of 2 cubed has to be 0, right? So you solve this one, what you get? F of 2 has to be 1, correct? Yes or no?
Yes.
Something confusing? So remember the limit exists by L'Hopital. L'Hopital removes a 0 over 0 with the derivatives. Okay, but to be 0 over 0, this has to be 0, this has to be 0. So I don't have to go to the derivatives. Simply, I have to what? I have to evaluate this at the bottom, has to be 0 in 2, so f of 2 has to be 1. Okay, I have the first answer. F of 2 is 1, correct? Now I need f prime in 2. Okay, guys, ahora sí a sufrir. F prime in 2. How much is f prime
in 2? Get the derivative.
Well, let's see. Let me just move this to the right a little bit. Yeah.
It's going to be 0.
Let's see. So f prime into, so limit when the x is approaching 2 of h of x is, remember what is h, is this over this. So it's going to be the derivative of this top and the derivative of this one. Okay, what is the derivative of the top? 2x over. What is the derivative of the bottom? Is the power of a function. So I have to do the power and then f prime. So it's okay. Let me see. It's 3 f of x s squared times f prime of x. Correct? So is the limit, let me see. Let me just put it right here correctly. Limit when of h of x when x approach 2 is the limit when x approach 2 of 2x over 3 or negative 3 f of x s squared times f prime of x. Okay, so what I did? Well, because this function of this function is undefined and I cannot simplify anything here. So I have to use L'Hopital. So I have to use the derivative of the top over the derivative of the bottom. So the derivative of the top is this and the derivative of the bottom is this one. So what is the limit then? So what is f prime of 2? How do you find f prime of 2? No idea? So let me just put this one. Evaluate the limit of death. So
f
this
prime of 2.
2 times 2 over negative 3 times f of 2 squared times f prime of 2, right? And this has to be equal something, correct? Because if this equals something, I can solve this one. 2 times 2 is 4. This is 1. I found it here. F of 2 is 1. So this is negative 3 times f prime of 2. And this has to be equal something here such that I can find f prime in 2. Okay. What is in the square? Can you find something on the square? The value in the square? Nothing? Something?
No, because of what's the derivative of f? What's f prime?
No. It's a difficult problem because you have to go to the thing. But let's see what the problem says. Let's see what the problem says. We have to read the problem again. Yeah. Okay. The functions are twice differentiable and h of 2 is 4. Nothing? It's not telling you something? What does mean a function is differentiable? A ver, Brandon, before you fall asleep. What does mean a function is differentiable? The function is broken or is continuous?
No, mira, Ramirez. Differentiable significa que you can put a pencil on it and the pencil, you can keep the pencil there. It's connected.
Correct. But, vamos a ver. Let me just go back to the concept. Let me just open a board. Let me just go back to that concept. A ver. This function is continuous, correct? This function is continuous, but is not differentiable here, correct? This function is continuous and is differentiable. So this is the point. If the function is differentiable, is continuous. If a function is only continuous, not necessarily is differentiable. You may have peaks. The point here is this one, right? The point here is this one. The problem says, the functions f, g, and h are twice differentiable. right? So G of 2 is equals H of 2 equals 4. So here is a piece of information that is important. H of 2 equals 4. So let me just go back to my board, here in my board. What is the limit of a function at a point when it's differentiable of continuous? So the limit, if this is f of x, the limit of f of x when x approaches c, suppose this is z, right, is f of z, correct? Everybody? So what I was asking you, what is the limit of h in 2? So, well, because this function is differentiable and continuous, here is the value. H of 2 is 4, so the limit is 4. Everybody catch that? Yeah?
What?
Uh-huh. So what I have to put here is a 4. Correct?
Mm-hmm.
Because this is, let me just put here, H of 2, because it's continuous and differential. H of 2 is 4. Now, what is the value of f prime of 2? Value of f prime of 2 is negative what?
Hold on.
Just solve this one, come on.
Negative 1/3.
Negative 1/3, correct.
Oh.
Yes, it's just solve this one. You cancel the
Couldn't figure
4,
that.
and then you move
Yeah.
this to the other side, it's negative 1/3.
Oh, you cancel the 4?
Claro. You can divide by 4 everything, you cancel the 4s. Okay. Okay. You see, these problems are weird, correct? You don't see here sines, cosines, polynomials, but these points require you understand the concepts. You see, the simple concept that you have something differentiable, the limit of a function at a point is the value of the function there. So you have that this limit is h of 2. Then with this limit and this L'Hopital derivative over derivative, you find f prime of 2, of course, chain rule, and then you solve. No questions here? Everything clear? Okay, Leo is gone, I see. Okay.
Yeah, his computer died.
Okay. Last question.
I just have a question.
Yes, sir.
I have a question about the homework. When's it due?
Saturday.
Okay.
Okay. The last question. Yeah. It's known that g of x is less than h of x in the interval 1, 3. Let k be a function satisfied that is between them for 1, 3. If k is continuous at x, is k continuous at x equals 2? Justify your answer. It's, oh my God. Is k continuous at x equals 2? Justify your answer. So let me see. Let me just put that one right here, and we finish with this one today. So they say that g of x is less than h of x, from 1 less than x less than 3, right? And yeah, then g of x less or equal than k of x, less or equal than h of x. So k of x continues at x equals 2, I mean. Okay, let's see. This is what we have, correct? These are my assumption. These two functions, one is less or equal than the other one. The g is always below the x, the hx. And you have a second function that is always between these two. Now what you have this one now. The hypothesis in the problem says that g of 2 equals h of 2, and this is 4, correct? Right? This is what you know. This is at the beginning of the problem. G of 2 equals H of 2 equals 4. So if we take the limit, right? Yeah. The limit, right, of G of X when X approach 2 less or equal than the limit of K of X when H equals 2 less or equal than the limit of H of X when H approach 2, this is going to be 4 and this is going to be 4. So is 4 less or equal than the limit of K of X when H approach 2, 2 is 4. So this means that the limit of K of X when H approach 2 is 4, correct? But here is the question, is what you know from this inequality and this information, if you take the limit of this in 2, the limit of this in 2, you can find the limit of this in 2, correct? So you know that the limit of this function in 2 is 4 also. But now here comes the question. If the limit exists, the function has to be continuous. Yes. If
Yep.
limit of f of x when x approach c equals L means, is thus, lim of f of x when x approach c equals L means f of x continues at x equals c. Right here, this is what I wrote. Does the limit equals x means that f of x continues at c? So you don't know anything about k of x in 2. The only you know is that is between them. I want you to remember this. If you have this function with a hole here, and this is, for instance, 2, and this is, for instance, 3, and this is fx, what is the limit when x approach 3 of f of x? A ver, Areli, what is this limit?
Dos.
Correct. My question is, the limit exists, correct? Is the function continuous?
No.
No. So the only you know is the limit of this function exists, but you don't have any other information about k. So may happen that the function be continuous, but not only the limit existence, not only the existence of the limit warranties that the function is continuous. Limit only does not warranty continuity. All right. So that's what you have to answer. If they tell you, okay, if k of x equals 4, of course, because it's the same point right here, 4. So you have a value. So the point, the limit is the same as the value of the function. So you have here, fill the gap. But only the limit does not warranty the continuity. So the function is not necessarily continuous. Okay? Everybody clear? So you see what happened last year when the kids took this test? It was weird. These were the problems they were solving. Okay? Okay, tomorrow.
Did anyone pass last year?
Eh?
Did anyone pass last year?
No.
Nobody. Not William Blaisdell, not
¿Cómo se llamaba? Darkin o cómo?
Dargen.
There